All right, ladies and gentlemen, welcome to example number 1 from chapter 14.1. This is take number 4, so hopefully this will go well. All right, the Advanced Placement AP Statistics exam was first administered in May 1997. Students' papers are graded on a scale of 1 to 5, which you all know already. Most of you have taken an AP class before, with 5 being the highest score. Over 7,600 students took the exam in the first year, and the distribution of scores was as follows, not including the exams that were scored late. All right, so in 1997, 15.3%, this is percent, of the students scored a 5. 22% scored a 4, 24% scored a 3, 19.8% scored a 2, and 18.1% scored a 1. Now, when working with percents, please remember to always change them to decimals. Now, remember, this is the whole populations. This is our parameter. Okay? This is our parameter. That was all of the students in 1997. Now, there was a class, a distance learning class, that took AP Statistics via satellite television. And that class had the following distribution. Okay, now notice right here it says frequency. Okay, that would mean 7 students in that class got a 5. 13 students got a 4, 7 students got a 3, 6 students got a 2, 2 students got a 1. Okay, so watch for frequency, watch for percents. Okay, now these are the observed. Okay, that's the class. Now, at any point during the video, if you need to pause to write stuff down, please do so, because I'm not going to pause between each step. So if you need time to write it down, pause it when you are ready. All right, so continuing. So the first thing we need to do, step 1, is write our hypothesis. Now remember, from the other sheet, our hypothesis has to be in the form of something is the same, or something will not change, or it's alike. Okay, so this is how I wrote this first one. Okay, we're going to carry out the test. Here we go. Here it is. So the hypothesis is that the distribution of scores for the distance learning class is the same as the distribution of scores of all the students who took the AP exam in 1997. Okay? So again, that class, the distribution is the same. So nothing is different. It matches what all of the students took. All right? And again, if you need more time to write that down, please pause. The alternative hypothesis would be almost the same thing, just change a few words. The distribution of scores for the distance learning class is different than the distribution of scores of all the students who took the AP exam in 1997. All right? There's your alternative. Okay, the next thing we're going to do is talk about the SRS. Okay? In this problem, it does not say that it is a simple random sample, but we're going to assume that it is. Okay, we must be willing to treat the sample of students from the distance learning program as an SRS. We do not need to write down proceed with caution. We're just going to go ahead and assume that it is a simple random sample. Okay, now the next thing we're going to need to do is figure out how many of these students in the distance learning class, how many we expect based on the information about the percent of all the students. We want to figure out, based on that, how many students would we expect to get a 5 in this class? How many would we expect to get a 4? How many would we expect to get a 3? How many would we expect to get a 2? How many we would expect to get a 1? Again, these are the observed values. These are the actual counts. But we have to go through and figure out what we would actually expect. That's why we needed to change these percentages into decimals. Now, how many students are in this class? Well, that's easy. We have to use the frequency. 7 plus 13 plus 7 plus 6 plus 2 equals 35. So there are 35 students in this class. All right, so expected counts. The first thing we need to do is take, okay, so here, I'll just pull this down. All right, so you see that, again, these are the fives. 0.153, remember 15.3% of all the students got fives. So take the number of students times the decimal, and this is our expected count. So we expect 5.355 students to get a 5 from that class based on the national average. Okay, that is the expected count. Now, yes, we can't have part of a person, but we want to use decimals here. Okay, we usually want to go 2 to 3 decimal places. Okay, now the 4s. Okay, 22% of all of the students received 4. So take 22% times 35, and we get 7.7. Again, that is the expected. Okay, let's keep going. Now the 3s. 35 times the 0.248. Again, look up above where I got these numbers, and we expect 8.68 students to get 3s. Okay, 35 times the 0.198. We expect 6.93 students to get 2s from that class. And then 1s, 35 times 0.181, we get 6.335. Again, that is what is expected. All right, now, there's one more condition we need to look at, okay? Since all the expected counts are greater than 5, we can proceed with the chi-square goodness of fit test. Okay? So, they're all bigger than 1. If you go back and look at the conditions from that other sheet, all are greater than 1, and none are less than 5. Okay, so we don't have to really think about it. Okay, they're all bigger than 5. That's excellent. All right, so now what we're going to do is we're going to do a little math here. All right, so we're going to take the observed minus the expected squared divided by the expected. Okay, and I forgot to put the sum in there. We're going to take the sum of that. All right, here we go. So, 5s. Okay, there were 7 students who got a 5 minus the expected 5.355 squared divided by 5.355 plus. Okay, now the 4s. There were 13 students that got 4s minus the expected squared divided by the expected. Plus, okay, there were 7 students who got 3s. So 7 minus, now the expected was 8.68 squared divided by 8.68. Plus the students who got 2s. Okay, well, there were 6 students who got 2s minus the expected 6.93 squared divided by 6.93. And the number of students who got 1s. Okay, there were 2 students who got 1s minus the expected of 6.335 squared divided by 6.335. Okay, if we type all of that into the calculator, we end up getting 7.57. Okay, now we're going to use our calculator and use the lists in our calculator to help us with that. Okay, you're going to have to go to part 3 to continue.